I got a bit of bonus content for you today, and it's all about metal fabrication. So if you've got a trailer or a shed or a workshop or something of that nature and you build stuff in it, this one is for you, okay? And it strikes me that a lot of dudes who care about cars care about that kind of stuff as well. If there's a Venn diagram, there's a fair bit of overlap between those two circles, and I want to talk about that. Now, it strikes me that if you're building, I don't know, a workbench or something of that nature, a gate, it doesn't matter what it is, or a small section of decorative fencing, a ramp for your trailer to get a ride-on mower up there, or even the push mower to make that a bit easier, then you're going to have to cut up some standard structural shapes, and you're going to have to cut them into the right length. And there's going to be a lot of repetitive cutting, because if you're going to make a ramp for your trailer, for example, you might have to cut up 20 bits to go in between the stringers, and they're all going to have to be the same length. And if you're using an angle grinder to do that, it's going to be a proper pain in the ass, because you're going to have to mark each piece out individually. And that kind of sucks, because to mark out metal, you've got to measure it roughly, color it in a bit with a marker or blue or something of that nature. Then you got to measure it precisely, mark it with a scriber, get a square, scribe the right line. And in the case of the angle grinder, if you're cutting up this stuff, like a bit of square section tube, then you've got to mark a 90-degree line on each bit and kind of follow that around the angle grinder. And it takes until the frickin' heat death of the universe, okay? But there is an easier way, and the easier way would be to start thinking more like a machinist and less like a DIY punter. See, in the machining universe, there's a concept called a reference surface, and it's used all the time on a drill press or a vise on a drill press, I should say. If you've got that clamped down, then the fixture or the vise is a reference surface, and it ensures the repeatable insertion of material. If it's all the same size material, the drill's going to come down relative to the fixed jaw on the vise in the same spot. And if you use the edge of the vise as another reference surface, you can use your trusty 1-2-3 block or something to put the workpiece against the vise, slide it against the edge of the vise like this, and then all of a sudden your drill is coming down in the same spot all the time, so you don't have to mark out a single hole once you've got it all set up. And this is kind of that applied to DIY in the shed fabrication of this and that. And the concept I'm talking about is a stop block. And I'm just going to set it up for you here philosophically, and from time to time we're going to cut away to an actual job I was doing at the weekend, because like since Christmas I've been living the fabrication life, because we need a couple of privacy screens here at home, and I'm cutting them up with 50 by 50 square section tube, 3mm thick, and that's for the main exterior frame. And then the internal supports like the ribs, the whatever you call them, joists, they're 25 by 25 by 3, that's this stuff. And a lot of that cutting is repetitive, and I freaking hate marking out because it's so time dependent, and it also introduces more errors than a setup with the reference surface, because once you're set up and clamped off with a reference surface, there's no measurement error. Your setup is your setup, and you just feed material in and cut it up till the cows come home. In this situation, I'm using this inexpensive Vevor bandsaw. It's a great tool for cutting up metal. You can buy it in two flavors actually. You can buy it with this table that allows you to use it as a cut-off saw. The table also swivels as a miter saw. I'm not going to go into it in great detail because I've done a review on that. I'll put a link up there to a card, to a card up there. It's up there. Whatever, somewhere up there, there'll be a link to the review video on this saw. The other version of this saw is just as a standalone handheld job. Now, I would strongly advise you, if you're thinking about lifting your game up from angle grinder cutting to a saw on a bench to cut metal, I'd advise you to go for this version with the table, because A, it doesn't cost you much more, and B, if you want a handheld one to break something down in the field, you just undo like 3 socket head cap screws here, and it lifts off and you've got that. So the versatility of this is well worth the small additional cost. And I did check with Vevor. They got plenty of these in stock. They've just received a new shipment. So I think they're under $300, which to me is just tremendous value for something that lifts your game so much. Now, the reason I hate angle grinders is a few reasons. One, they're freaking dangerous. And of all the things that they're good at, and I use them all the time, angle grinders, I've got 5 of them just over here, and they're all set up for different jobs, and one of them is cutting metal, okay? But that's the thing that angle grinders are the worst at, okay? So I just hate using them for that. The blades are flimsy, they're dangerous, they fill the air with toxic grinding dust, so you have to wear breathing protection in addition to the eye protection that you should almost always wear when you're using any kind of power tool. So that kind of sucks. And these are just a low fuss way of cutting through common structural shapes that you would use in your home workshop. All right, so the philosophical thing is this, okay? You've got a vise on the table in the saw that holds the material, and if you clamp the saw to your bench in position, then that's fixed relative to the bench. And if you mark out one thing to the right length, then you set it up in your vise and you clamp it off, this cut is going to happen just fine. And you've already done a finishing cut on this bit, okay? That's the theory. So this bit is going to come off. It's exactly the right length. You've taken your time and you've marked it out accurately. What you then do is you get something convenient and you clamp it to the bench right there. When you do this cut, that bit falls to the ground. You just lift your saw up, you unclamp the work, you feed the next bit through till it hits your stop block, you clamp it off, you go again. And I recently had to do 5 pieces. The internal ribs all had to be the same length. And this is another mistake that people make when they DIY something out of steel in particular. They sort of build it on the floor or on the bench and they make the bits join up, but they don't pay enough heed to the dimensions on the drawing if they have one. So if one of these bits is 3 millimeters too long and another bit is 2 millimeters too short or something, and you've got this arbitrary collection of dodgy length bits, then when you weld them all up into the project, it pulls the project out of shape. And that's why so many DIY jobs, not only are they not parallel, but they're not square, so they're kind of rhombuses or whatever you call that. And not only that, they're twisted this way or this way because the joints were all cut so freaking dodgy. So if you're going to make stuff out of steel, you should put processes in place and have a mindset where the accuracy of the bits in the cut list really matters. Because guess what, dude? It really matters. I'm cutting out these ribs out there because it's as hot as, 2 rats screwing in a wool sock in the jungle. And there's a bit of breeze out there. So I'm doing it outside and I've got the saw clamped down and I've got the stop block, which is just a scrap piece of steel. It's clamped to the bench, and I wanted to show you the classic mistake that people make with their stop blocks. And this is still relative to what I would call a low kinetic energy saw like this. It's got low kinetic energy because the blade is very light and it doesn't move very fast. And intrinsically, that makes it safe. Now, incidentally, if you're going to use any kind of cut-off saw, don't stand here. Don't stand here in line with the blade. If you stand here, this is the bit that's about to be disconnected, so it could go flying off. So don't stand here, okay? Like if it hits the saw and bounces back, it's like a piece of metal hitting you in the guts, potentially bad. If you're using a high energy saw, it's a disc rotating like this, and you're in the plane of rotation. So if something fails, where do you reckon it's gonna go? Into you. And wearing the right protection, like safety specs or something, I've got a million pairs of safety specs here. But the thing about safety specs, they've got the standards mark on them, AS 1337 medium impact, so you think, yeah, I'm protected. It's only part of a safe working system. you cannot stand in the plane of rotation. So don't stand here, dude. Like, what I do is I stand on the vice side of any saw, because this work is fixed to the saw, and the saw is between me and anything that goes flying. And then I'm out of the plane of rotation, and I can still see WTF is happening down here. So you've got to have these overlapping sort of philosophical protection attitudes as well. But even in a low kinetic energy saw like this, what happens is you've got zero clearance between the stop block and the blade. And when the work comes loose, it can kink itself like that against the stop block and against the blade where there's no clearance. And obviously, as it moves like this on the diagonal, because it's a three-dimensional shape, it gets longer and it jams itself between the blade and the stop block. And that means the blade is going to carry it somewhere, and some of that kinetic energy is going to mean it bounces off energetically. So even with a low kinetic energy safe kind of saw like this, a stop block configuration like that is potentially dangerous, because it always involves this sort of elastic rebound effect. But you can take it away really easily. So here's how you do that. Let's go back to not having the work set up yet. Okay, we've got one piece marked out appropriately. So we think it's going to be about here, but I'm just going to put a packer under this. I'm going to get one of my trusty 1, 2, 3 blocks. If you're not familiar with a 1, 2, 3 block, it's a precision ground piece of hardened steel that's 1 inch by 2 inches by 3 inches. They come in pairs. They're pretty cheap, so you can abuse the crap out of them. This is my abuse the crap out of it pair, but it's still good enough to use on a mill, you know, for non-aerospace jobs. They're pretty robust, in other words. So what I would do, and this is particularly important with a high kinetic energy saw like a tungsten carbide tipped metal cutting saw, and I will put a link somewhere up there to the one of those that I've reviewed as well, and they are fantastic for bigger sections, you know, like 50 by 50 and 75 by 50, up to about 100 by 100. They're really good, and they do it fast and they do it cool, that you can pick the pieces up immediately afterwards, and they're very clean cuts, so you don't have to spend forever cleaning them up, and they're just super consistent. Okay, so a tungsten carbide tipped metal cutting saw is fantastic if you're going to do a lot of fabrication. I got a couple there. I use them all the time. The only downside is they just shower the universe with metal chips, like the metal equivalent of sawdust, which would be Satan's fingernails. So you'd have to have something to deal with that. And the something of choice, which I've just upgraded to, I've wanted one for ages, is one of these babies. It's a magnetic rake thingo. So you've got chips all over the concrete where you're going to park the car. You just whip all over it with it. The magnet along here just sucks up all the magnetic chips, and then you just pull the release handle here and it pulls the magnet out of alignment, and you just, you know, get rid of them in the bin. It's awesome. Makes cleanup so quick if you don't destroy the rest of your workshop with it in the process, right? So anyway, that's the downside to these faster high kinetic energy saws, and they're potentially more dangerous as well. So you've got to make sure you're wearing the right eye protection. You've got to get out of the plane of rotation and all that stuff as discussed. That's kind of really important. The other thing I'd suggest about most saws is that if you end up in a position where the piece that you are cutting, you've cut through, right? And the piece that you are cutting is kind of sitting there. You've taken your finger off the trigger of the blade, so the saw is spooling down, but it's still got a lot of kinetic energy. Like, it's still turning and burning, right? Don't lift it up until it stops, because the actual tungsten carbide tips on the blades of these metal cutting saws are a fair bit wider than the steel disc that they're brazed to, and they can pick up the work on the way up and throw it, right? So if the work hasn't just fallen away and gone down onto the bench, wait for the blade to stop before you let it up. That's a pretty good safety tip as well. And be standing on this side away from that, because that's a real risk with a high energy saw. Anyway, you've got your 1, 2, 3 block set up like this. You've got your piece marked out. And then what you do is you set your piece up like this, and if necessary, you tweak, you know, the location of whatever here before you clamp it off. You just tweak that so that you get your mark in position, you check it, it's right, stop block in place, clamp down. Before you cut it, you pull your 1, 2, 3 block out. And then you've just engineered an inch worth of clearance between the cut-off piece of work that you're about to manufacture. The work piece is about to come off, and it's got an inch worth of clearance that you didn't have in the previous setup. So the work piece can just fall off the saw without getting bound up in the manner of the previous one. And I'd suggest that it's a good idea to do that all the time. This would be the best practice option for stop blocks everywhere, okay? I'd have to say though, the shorter the piece, the easier it is for the saw to pick it up and throw it around, and the more critical it is to use something like that, at least in my opinion. And it takes bugger all extra time to do this, right? It's a really quick hack, and it gives you the clearance you didn't have before. You're just on the saw, you go through the whole thing again, and then you just whip it through. It's a production line. It's super easy to do, and instead of in one of the privacy screens that I made up, there's like an outside frame out of 50 by 50, and the inside frame is made out of this stuff. And it's got 5 vertical ribs that go in it that serve 2 purposes. The first one is it's something to attach the cladding to, right? And the cladding just sits inside the frame because the cladding's about 23 millimeters thick. So these are against the back of the 50 by 50, and it gives you 25 clearance on top, and it just fills in that void, right? So screw straight through into that with self-tappers, brilliant. And the other thing is, when you weld long bits of steel together, you introduce residual stresses into the joints, and the most common outcome for me, even if I take a great deal of time to set up a jig and clamp it all down, is that the residual stresses tend to pull any miter joint like this out of 90 degrees, more like an acute angle. Not that much. And so over about, I don't know, 3 meters of length, you're probably looking at maybe 6 millimeters of bow in the longer members. And obviously the longer you make something, the less rigid it is. The stiffness of a beam is proportional to the cube of its length. So if you double the length, it's 8 times floppier kind of thing. So length makes a real difference to deflection. And you've got to come up with a deflection countermeasure if you don't want your work to look properly shit. I hate it when this happens. Stand by. Honey bunny. It's like a 4th law of thermodynamics, isn't there? Which would be, when you hit record, the phone's going to ring. And it's going to be your missus, and there's not going to be any acceptable excuse for not picking up, okay? So anyway, now that we've got that out of the way, the second purpose to have these ribs in a frame like that is to counteract this bowing, right? The only way you can counteract that is if you make the ribs consistently long. They've got to be the same length. And they have to be the right length. They have to be the length on the frickin' drawing. And you have to make your frame to the drawing and not just hope that you got the cuts right with your angle grinder and then hope that it turns out okay and hope that these ribs kind of fit in okay. That's not the way to do this, at least in my view. If you want to be a pro at this, you've got to say, okay, I'm going to make it that shape. These are the dimensions. It's going to be that shape. I don't think we have to be all Elon Musk about this and send an email to ourselves saying microns count, because they don't. In a workbench, for example, microns don't count, but millimeters do. And a setup like this allows you to achieve consistency, certainly within 1 millimeter. Like, all you've got to do is have the saw clamped down properly and the end stop clamped down properly, like it's going nowhere for the duration of the cutting that you're doing. And your 1, 2, 3 block's not going to change and the vise isn't going to move. And as long as you're consistent in the way you slide the material through and clamp it up, then all of the pieces that you produce are going to be within about 1 millimetre of each other, which is freaking precise in a shed, building a workbench or a privacy screen or a piece of fencing or a gate or ramps for your freaking trailer, which is what we're talking about here. Obviously, if you're dialing something in on a milling machine, then microns matter, you know. 50 microns might be the kind of order of accuracy that you're after there, but we're not talking about that here. We're talking about within about 1 millimetre. And when you look at the results, I'm getting easily within 1 millimetre and I'm only measuring once. Measuring once, cutting 5 or 6 parts. And you can also use it for sexing up the work afterwards. Like I had to do all of these little support platforms for one end. It's complex. Anyway, don't worry about why, just worry about the what. I had to make these. So I cut them off square and then I cut these chamfers afterwards, whatever you call them. I think they're chamfers still. Anyway, miters, I guess it depends on the orientation, doesn't it? Certainly not splays. So anyway, I had to cut them off and I wanted them all to be the same. So this is the same deal, only with the saw set up for mitering and with the stop block in a different location. And then to get a dozen completely consistent miters and only measure one, all you do is get all your pizzas that have been cut off square, slide them through to the stop block, cut your miter, chamfer, not a splay, and then flip it, go again, put all the pieces down. You can check the result. And then all you got to do after that is go over to your linisher and just do a quick tidy up on that, get the burrs off, and maybe the burrs that you can't touch with the linisher, just get into it here with the wire wheel and do a fair old job with that so that, you know, it's reasonable to handle. You're not going to cut yourself making it, and nobody's going to cut themselves if they've got to reach up to it later on, even though the location is fairly inaccessible. So anyway, that's just a concept that you should play with if you've got to do some of this stuff. That's about all I've got for you on this video. I will put a link to this bandsaw and also the tungsten carbide tipped metal cutting circular saw as well. That's a great idea if you're going to do a lot of fabrication and time is a factor. This is probably the safest option to start with after you've been using an angle grinder to do everything. All right, and angle grinders have their place, I get that. Pick yourself up some 1, 2, 3 blocks. They are miraculous little tools. They're precision squares and shims, and you can bolt them together and make squares like that. And when you've got one, you will never cease to be amazed how many things it can be used for, including setting the blade of a saw up square to the fixture on the vise and things of that nature as well. So anyway, I hope this has opened your mind to the concept of reference surfaces, which can exist anywhere. Drill presses, milling machines, lathes, cut-off saws, every machining operation that does not involve a handheld power tool has the potential to incorporate a reference surface that just slashes the burden of marking out. And you get all that time back. You can use that extra time to watch the footy and drink beer, or be more productive, or be more precise, whatever counts for you, right? So anyway, if you're a welder or a boilermaker, I know you are better at this than me. I'm not claiming to be a full-on professional metal fabricator, but I did work in those environments for a few years when I trained to be an engineer, and my objective with this video is to open people's minds in DIY land to a perhaps more professional way of looking at doing this kind of stuff so that they can be safer and more productive. And if there's something else that you'd like me to cover off in that domain, if I know about it, I will. Let me know in the comments.